Pluto continues to divide scientific minds. Discovered in 1930, the celestial body was a permanent member of our planetary system for over 75 years. In 2006, however, the galactic turnaround followed. As more and more Pluto-like objects were identified in the Kuiper Belt, the International Astronomical Union decided to rethink the official planet definition. As a result, Pluto was placed in the newly opened ranks of dwarf planets, of which it has since become the largest known representative. In view of the decades-long history of research and the great controversies surrounding Pluto, it seems all the more astonishing that for a long time, nothing more than blurry images existed of the remote celestial body, making a detailed insight into this distant world impossible. In order to finally change this, NASA's New Horizons spacecraft went to the remote realms of the dwarf planet on January 19, 2006, to study Pluto at close range for the first time. The transmission of the data that the unmanned spacecraft collected over Pluto during this time ended on October 25, 2016. Since then, New Horizons' primary mission has been over, and when a spacecraft will next set off for the dwarf planet is currently only written in the stars. The breathtaking images taken by the technical equipment during its mission therefore represent the last images of the former planet for an indefinite period of time. So today, let's take a closer look at the fascinating photos and findings that New Horizons captured and revealed. Interested in learning more about the groundbreaking discoveries and distinctive spectacles in the cosmos on a regular basis? Then remember to subscribe to Simply Space and click the bell to never miss one of our videos again. By giving us a thumbs up, you're motivating us and showing that we can keep you engaged with the content of our posts. Pluto, a short overview. To understand why Pluto was banned from our local planetary system, we should first answer a basic question. What actually is a planet? According to the current definition of the IAU, a celestial body must fulfill 3 requirements to be included in the corresponding ranks. Its orbit must lead it around the Sun, it must have an approximately spherical shape, and it must be the dominant celestial body in its orbit. Or in other words, it must have cleared this orbit from other objects by its gravitational field. It was just this last point that sealed Pluto's planetary end. With an equatorial diameter of 1,475 miles, the dwarf planet is significantly smaller than the Earth's moon. Our constant companion has a value of around 2,159 miles in this category. While our Earth is known to take 365 days to complete its orbit around the Sun, Pluto takes more than 247 years to complete the same task. While the dwarf planet travels through space, it's sometimes 49.3 astronomical units away from the Sun. The celestial body never comes closer than 29.7 AU to our central star. Again, a brief explanation. The astronomical unit corresponds to the approximate distance between Sun and Earth, thus about 90 million miles. The bitterly cold temperatures that prevail on Pluto are also due to its location far from the Sun. On average, the thermometer here drops to -404 degrees Fahrenheit. In terms of its structure, the dwarf planet can be compared to Neptune's moon Triton. A gigantic rocky core is followed by a layer of water ice, which in turn is surrounded by nitrogen ice. We now know that Pluto is not traveling alone during its journey through space. It is accompanied by at least 5 natural satellites. The largest Pluto moon by far is named Charon. In detail, the 2 celestial bodies have a double-bound rotation, which means that they always face one and the same side. With an average diameter of about 745 miles, Charon is half the size of its cosmic counterpart. As a result of these size ratios, experts have been discussing for some time whether it would not make more sense to speak of the double system Pluto-Charon. Below the atmosphere, which is mainly composed of nitrogen, the fascinating surface of the dwarf planet greets us. On an area roughly equal to that of the South American continent, we find the most diverse plains and formations, from gigantic ice surfaces to the mighty 11,500-foot-high Norgay Montes. to unique reliefs reminiscent of the skin of a snake, Pluto impressively shows us the natural diversity of the cosmos. Spectacular images. On July 14, 2015, the time had finally come. After a 9-year flight, New Horizons swung into the realms of Pluto, giving us a detailed look at the remote dwarf planetary world for the first time in history. During its research mission, the spacecraft approached within 7,800 miles of the celestial body, capturing countless high-resolution images of Pluto and its companion Charon. As a result of the immense distance that gaped between the $700 million piece of equipment and Earth, it took more than 15 months to transmit all of the collected data. But it was worth the wait. In the following clips, we would like to present some of the most impressive images that New Horizons has provided for us. First, let's look at the color-enhanced overall view of the dwarf planet. While the image leaves us in pure awe with its overwhelming detail, it is also of unparalleled value to scientists. Based on the differently colored regions, the experts can understand how their chemical composition is formed. Accordingly, it can be clearly seen how the right area, the so-called Tombo Regio, is divided into 2 distinct regions. The left bulge of this heart-shaped area, the Sputnik Planitia, is remarkably smooth. Speaking of Sputnik Planitia, thanks to New Horizons, we know that Pluto is repeatedly the scene of an exotic ice flow. The close-up images of the ice plain show that the frozen-out mass has moved over time, much like terrestrial glaciers do. In addition, the data collected suggests that Sputnik Planitia's center is rich in nitrogen, carbon monoxide, and methane ice. The frigid surface temperatures allow these frozen-out materials to move as if by magic. Fascinating landscapes. After New Horizons had completed its closest approach to Pluto, it went back to more remote areas. However, the complex technical equipment did not miss the opportunity to take a photographic look back, which is why we are able to enjoy the following image. As you can easily see, the captured landscape is bursting with detail. From a distance of about 11,000 miles, we can see a rugged mountain plain on the left edge of the image, the Norgay months already briefly mentioned. If we now let our gaze wander toward the horizon, we catch sight of the Hillary months. These massifs also tower up to almost 11,500 feet above the landscape. We also see the impressive dimensions of Sputnik Planitia here. The icy plain in the Tombo Regio covers an area of roughly 650 by 500 miles. Above these strangely familiar-looking formations, the thin atmosphere of the dwarf planet becomes invisible. This high-resolution image shows how unusually sharp the subdivision of the individual structures can sometimes be. On the left are the so-called Al-Idrisi months, rugged highlands, consisting mainly of frozen nitrogen. And on the right, Sputnik Planitia greets us once again. Why the individual plains are divided into different segments and are adorned by numerous pits is so far an unsolved mystery. Snakeskin terrain. At first glance, the next photograph appears to show only an unusually shaped formation with a striking texture, reminiscent of a snake's skin. From the expert's point of view, the photo possibly gives us a significantly deeper insight, namely, into the conditions of the proto-solar nebula from which our solar system once emerged. Located in the Tartarus Dorsa region, an elevation model created by New Horizons shows that the snakeskin formations have a height of about 1,600 feet. At the same time, we are dealing with some of Pluto's most steeply rising structures. However, the spectroscopic measurements of the region should cause some question marks over the heads of the experts. According to the data, the area in question is mainly composed of methane, complemented by a small amount of water. Because of this composition, the scientists asked themselves the following question. Given Pluto's gravity and surface temperatures, can pure methane ice be capable of maintaining such steep formations over long geological periods? The telling answer is, perhaps. In fact, the few studies that have been conducted in this regard so far paint completely different pictures. One theory is based on the fact that the snakeskin terrain is composed of methane hydrate. Some studies strongly suggest that this ice-like substance already formed in the interstellar medium before it eventually became part of the solar nebula. In other words, methane hydrate may be among the oldest materials in the solar system. The dwarf planet at night. At first glance, it would seem that the image of Pluto's night side would reveal few details, but that's not true. While the sun hides behind the secluded astronomical world, plunging its backside into impenetrable darkness, we can make out a crescent-shaped area on the upper part of the celestial body, showing us the shadowy landscape formations. The natural atmosphere, in the form of a multi-layered nebula complex, is also clearly visible in this dim image. At the time of the photo, New Horizons was about 12,000 miles from Pluto. Now it's time for your opinion. Which Pluto image captivated you the most? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest. Take care, and we'll see you next time.